I had a quick question for you. If you had a button that could fast forward your life, would you have pressed it by now? I know I certainly would have, but alas, it seems that such technology is lost only to the realm of science fiction. Or is it? In fact, science has actually shown that time travel to the future is actually possible, although it's not actually technically in button form yet, and no one's ever done it before, so you might need to wait out this fun little time. But it is possible, and today I'm going to show you just exactly how. Now this all started with Einstein, because let's face it, almost everything in physics started with Einstein. But before we start with Einstein, we need to get one thing very clear. The universe has a speed limit, and that speed limit is the speed of light. Now usually we don't think of light as having a speed, because looking out the window, I don't see any lag out there. It doesn't have to travel to me. It looks like it's coming to me instantly. But it's not. It just almost is. Light travels at a whopping speed of 186,000 miles per second, and usually that isn't very noticeable. To put that into perspective, that's as fast as you would take to go to the moon and back in 1 second, or to go around the Earth just over 7 times in a second. So, looking across the road, you're not going to see much of a difference. But on an astronomical scale, that can have a difference. Like, for instance, the light that we see from the sun, that's actually what the sun looked like 8 minutes ago, because it takes just over 8 minutes for the light from the sun to travel all the way to our planet Earth. Now, back to Einstein. Einstein liked to tell these stories in which he would put himself in strange scenarios to figure out more things about the universe. He had one of these when he was on his trolley home from work. He was looking up at the clock tower in his town and watched as it slowly moved away from him. He wondered, what would happen if my trolley were moving faster? What about much faster? He thought, what would happen if the trolley he was standing in was moving away from the clock tower at the speed of light? Well, he reasoned, as the trolley moved away, the light from the tower would be racing to meet his eyes, but he would never get to see that because he was racing away from it at the same speed. And because he would never see that light, he would never get to see the clock's hands turn. Therefore, he reasoned, at the speed of light, nothing can experience time. Furthermore, if he had chosen to try to look at his watch, he would too not have seen those hands move either, because the light from the watch would have to move completely horizontally just to stay caught up with him, and if it moved up at any angle to meet his eyes, it would fall behind. So therefore, his hypothesis was correct. But what of the people on the ground? Well, the people on their ground, looking at their watches, much to the difference of Einstein, would of course see them moving at their usual pace, because they're not traveling at the speed of light. However, if they were able to catch a glimpse of Einstein's watch as he was traveling on the trolley, they would see that his watch was the one that wasn't moving. So with all of this strange time, the question becomes, what would happen when Einstein reaches his destination? Well, as the trolley slows down, time for him would speed up and up and up until it reaches once again its usual pace when the trolley stops. But as Einstein leaves the carriage, he would find not just a very different place, but a very different time. You see, the entire time that Einstein has been on the trolley, he hasn't been experiencing time at all. But that doesn't just affect his watch. That also means that he wasn't aging at all, and technically speaking, he couldn't have even had any conscious thought. So he doesn't remember anything that happened on the trolley. He doesn't even remember experiencing the trolley when it was moving at the speed of light. But of course, the people who were not on the trolley can clearly remember him just zipping around like crazy, and they could live their lives as normal. Now let's imagine that Einstein was on this trolley for 5 years. For the people, they'd just live their lives and occasionally maybe see him moving around, but they'd live those 5 years in their full. But for Einstein, he'd be basically unconscious for all of those years. And furthermore, he would not have aged during those 5 years. He wouldn't have experienced time at all. So when he gets off the trolley, for him, what he's done is he's gotten on a trolley, he's accelerated and accelerated, and then just as he's about to reach the speed of light, he suddenly starts decelerating. Because, of course, he doesn't remember ever reaching the speed of light. He only remembers almost reaching it and then slowing down. But for the people, they've still lived those 5 years. But Einstein, he doesn't remember those 5 years. So he hasn't aged, he's still not hungry, there's nothing that's changed since he reached the speed of light. So, in effect, he has just time traveled 5 years into the future. Einstein dubbed this whole phenomenon special relativity, and it goes way beyond just traveling at the speed of light. For instance, through a bunch of math that I will not even begin to pretend that I understand, he showed that traveling at any speed relative to something else could result in time dilation, although it doesn't mean that time will reduce as your speed increases linearly. He showed that until about you get to the speed of 70% the speed of light, you would notice very little time dilation, I believe only at max around 10%. And then, once you increase your speed from there, that is when you really start to feel the effects. And what is interesting is if you plotted these points on a graph with the y-axis showing how fast you were moving through time, and the x-axis showing how fast you were moving through space, it would produce a quarter of a circle. And the very interesting part is it shows that no matter what speed you are moving at, regardless of the speed of light, or if you're not moving at all, like me, I'm just sitting in this chair, you are always moving at a constant velocity of c. Because c is like the line that goes from the origin to any point along the circle. And of course, because it's a circle that is centered at the origin, the line will always be the same length, no matter what point you choose on the circle. Profoundly, not only is that time travel to the future very, very possible, but also that no matter what speed you are moving at, you always are moving at a constant speed through space-time, which is the combination of space and time. In conclusion, let's say you want to time travel. Definitely understandable, especially now. So what are you going to do? Well, first, you got to become a trillionaire. You got to hire the best scientists in the world. Maybe they'll come up with an invention. Probably not. But, theoretically it's possible that they come up with an invention that can push you almost to the speed of light, because traveling at the speed of light, unless you don't have any mass, is strictly impossible. But let's say you can almost get there. Well, you sit in your rocket, and you blast off, and maybe you blast off for let's say you blast off for 5 hours, and then come back to Earth. Now for you, you're still experiencing time as normal, because time hasn't stopped for you, because you're not moving at the speed of light. And from your perspective, if you looked at your watch, it'd still be ticking at the normal rate. But for everyone here on Earth, your watch would be super duper slow. And if you looked at their watches would appear super duper slow. But once you got back, everyone might have lived, depending on how fast your rocket is going, maybe a couple of years, maybe more, I don't know, whenever you want to travel to in the future. But you'll come back, you'll maybe, have sat in a rocket for 5 hours, that might be boring, but hey, you got to skip through all of this, so, it's your choice what you want to do. Now, one thing I must tell you real quick, time travel to the past is basically impossible unless new physics are discovered, because for that to happen, you'd effectively have to be moving faster than the speed of light, which is kind of a no in this universe. But, who knows? Maybe aliens will invent that. But, in any case, I'm sorry it's not in button form quite yet, and I'm sorry that this video hasn't gotten you anywhere except 10 minutes into the future-ish, which is pretty cool. I don't know exactly how much time I haven't edited it yet, but before we end the video, I would just like to mention one quick thing. You may have noticed that while I'm describing these super cool concepts to you, I haven't really had any friends to talk about it with. Now, why is that, you may be asking? Well, Astronomy Club, believe it or not, is actually the newest club here at West, which means that you don't exactly have, members yet, and you kind of want those when you're making a club. So I was just wondering, if you found this at all interesting, if you like learning about these concepts, we've got a bunch more planned for Astronomy Club that all sound crazy and fantastic, and they're super interesting when you learn about the actual physics behind them. So if you enjoy talking about these concepts, if you enjoy talking with others about these concepts, or if you just want to hang out after school, we have our first meeting February 9th, and as a club creator, I would be ever so thankful if you came and just tried it. You don't have to stay, you can leave, you can insult me afterwards if you want and never come back, but if you just want to try it just for one time, that would honestly make my day. So, in conclusion, while I'm sorry I can't offer you a crazy, amazing time-traveling device, I'm glad that you at least watched this video, and I hope you have a great rest of your day. Bye!